I mean, we've all been there, right? You're staring at your monitor at like 2 in the morning, just desperately trying to figure out why your Facebook lead ad data isn't parsing into HubSpot.
Oh, yeah, the absolute worst.
Right. And in that moment, you really don't care about the theoretical limits of your automation platform. You just want this stupid system to work.
Exactly. You're not thinking about architecture at 2 a.m.
No, you're just building these increasingly absurd workarounds just to get data from point A to point B. And that exact moment, that's what we call hitting the go-to-market wall. Your simple automations haven't just broken, but the fundamental architecture of your go-to-market infrastructure has basically buckled under its own weight.
Yeah, because the workflows that moved, say, 50 leads seamlessly yesterday, well, they become a massive liability when a new marketing campaign suddenly dumps like 5,000 leads onto that exact same logic. The underlying engines of tools like Zapier, Make, and n8n, they process data in vastly different ways. And, choosing the wrong processing model for your specific stage of growth is what actually causes that midnight crisis.
Which is exactly why we're going to tear down the architectural differences between those 3 major platforms today.
Welcome to the deep dive. Our mission here is to help you figure out how to scale your go-to-market automation infrastructure. We're pulling from a huge stack of sources for this: one industry guides, pricing breakdowns, platform documentation, and quite a few highly opinionated Reddit threads from developers who are actually in the trenches with this stuff.
The Reddit threads are always where the real truth comes out.
Oh, absolutely. So here's the roadmap. We're going to look at how these platforms manage branching logic, the hidden mathematical traps in their pricing models when your volume explodes, the harsh reality of self-hosting your infrastructure, and finally, how these tools act as the execution layer for AI agents.
Sounds like a solid plan. Yeah, so let's start at the absolute foundation, like how a platform interprets a single workflow. Because if you understand the data flow, you understand the platform's limitations. Zapier is, ubiquitous for a reason, but its processing model is inherently linear.
Right. Zapier's fundamental design philosophy is basically just a straight pipe. A trigger happens, and a sequence of actions follows one by one. And, it is brilliant for accessibility.
The ultimate low-barrier tool.
Exactly. You have a new strike charge, you want to create a QuickBooks receipt, and you want to post a notification in Slack. The data just flows sequentially from node 1 to node 2 to node 3. The platform totally abstracts away all the API headers, the authentication tokens, the JSON parsing. You just map the fields.
Just point and click. But the second you introduce variables to that straight pipe, the architecture starts to, strain.
Oh, big time.
Sure, Zapier has a feature called paths, where you can say, if the deal size is over $10,000, route it to enterprise sales. If it's under, route it to the mid-market team. But I've seen Zaps with nested paths inside of paths. And visually, it just becomes completely impossible to debug. You are clicking through endless drop-down menus, trying to find where the logic actually failed.
Yeah, because a linear engine is just not designed to be a complex decision tree. And the moment your workflow requires processing an array of data, Zapier hits a hard ceiling.
An array, like a list of items.
Exactly. Think about a Shopify order. It is not just one item. It's a payload containing an array. So a list of maybe 5 different products, each with its own SKU, its own tax rate, fulfillment status, all of that.
And processing that array is where Make really shines.
Oh, totally. Make approaches data completely differently. So instead of a linear sequence, Make uses a visual 2-dimensional canvas with native tools built specifically for data manipulation.
Right, it looks like a flowchart.
Yeah, and the critical component here is what they call the iterator. An iterator takes that Shopify array of 5 products and mechanically splits it into 5 separate parallel operations within the exact same workflow execution.
Wow.
Yeah, and then you can route each of those individual items through different logical branches using a router, process them all, and finally use an aggregator to bundle them back into a single payload to send off to your fulfillment center.
Okay, so think of it like this. Zapier is like a single conveyor belt in a factory. Items move down the line, getting stamped one by one. If an item needs special treatment, someone has to physically pull it off the belt.
I like that.
Make is more like a modern sorting facility with pneumatic tubes and diverter gates. You can split a box open, send the contents down 5 different chutes simultaneously, run them through different scanners, and then box them back up at the loading dock.
That is a perfect analogy. And the visual nature of those diverter gates in Make means a go-to-market ops manager can build incredibly complex programmatic SEO pipelines or dynamic lead scoring models without writing a single line of code. You can literally just visually trace the flow of data through the splitters and aggregators.
Which is awesome. But let's talk about the developer side, because n8n introduces a completely different paradigm here.
Yeah, it does.
Like, it looks like Make on the surface. It has a visual canvas with nodes and connections, but the underlying mechanics are really built for engineers.
The fundamental difference with n8n is that it doesn't force you to stay within its visual abstractions. It gives you an escape hatch.
An escape hash.
Yeah, in the form of a code node. So if you have an edge case where you need to run a super complex regex function, or maybe transform a deeply nested JSON object that the visual mappers are just struggling with,
Right.
a developer can drop a code node directly into the flow and just write native JavaScript or Python right there.
Okay, hold on, though. Bringing a developer in to write custom JavaScript just to parse a webhook sounds like a massive waste of engineering resources. I mean, if the goal is rapid go-to-market execution, dropping back into custom code kind of defeats the entire purpose of an automation platform, doesn't it?
Well, for a simple webhook, writing custom JavaScript is absolutely an inefficient use of time. You just use the visual mappers.
Yeah.
But consider a scenario involving API rate limits and unreliable third-party endpoints. In a standard visual tool, if an API call times out, the workflow simply fails. The lead just doesn't get routed.
It's just gone.
Exactly. But in n8n, you can architect native error handling. You can build a try-catch block visually.
Oh, that's interesting.
Yeah, you can instruct the workflow. Try to ping the Clearbit API for enrichment. If it times out, wait 60 seconds and retry. If it fails 3 times, branch the logic to a fallback data provider. And if that fails, alert a human in Slack without breaking the rest of the workflow execution.
Wow, okay. That level of resiliency is critical when you are processing thousands of leads. I mean, a 1% failure rate on 50 leads is just a rounding error.
Yeah.
But a 1% failure rate on 50,000 leads, that is a material loss of revenue.
Absolutely.
And that scale, moving from 10 executions a day to 10,000, that brings us to the mathematical traps hidden in the pricing models of these platforms.
Yes, the pricing traps are huge.
Because the computational cost of how these systems handle branching logic, it translates directly to your monthly invoice.
Right. The pricing paradigms dictate your system architecture just as much as the technical features do. Like, Zapier operates on a strict task-based model. Every time a successful action step runs, you burn a task. The trigger doesn't cost anything, but every subsequent node execution does.
So a 10-step Zap processing 1,000 leads consumes 10,000 tasks.
You got it.
Looking at their pricing documentation, a starter or a professional plan can just evaporate in a matter of days during a product launch. You are literally penalized for building thorough, multi-step workflows.
You really are. Now, Make uses an operations-based model, which sounds similar but has a pretty fatal flaw if you don't understand how APIs work.
Okay, what's the flaw?
Well, in Make, every single module execution counts as an operation. They give you a much higher volume of operations for a lower price. Often 10,000 operations for around $10 a month.
That sounds great.
It does. But remember that iterator we discussed earlier.
Right, splitting the arrays.
Exactly. If you use an iterator to split an array of 500 line items, and then you run each item through 3 subsequent steps, you just burned 1,500 operations in a single workflow run.
Oh, wow. In one run.
Yes. And the other massive trap with Make is polling.
Polling, like checking for updates.
Yeah. When an application doesn't support instant webhooks, meaning it can't actively push data to Make the second an event happens, Make has to constantly ask the application, hey, do you have new data?
Oh, I see where this is going.
Right. If you set Make to poll an inbox or an API endpoint every 5 minutes, that is 12 times an hour, 288 times a day, which is over 8,600 operations a month.
You are burning an entire subscription tier just knocking on an empty door.
Precisely, which is why n8n's execution-based pricing model fundamentally changes how you design systems.
How so?
Well, n8n counts an entire workflow from start to finish as one execution.
Wait, really? The whole thing?
The whole thing. A simple 2-node workflow routing a lead, and a massive 30-node workflow with iterators, external database queries, and custom JavaScript. They both cost exactly 1 execution credit.
That is wild. So you don't have to ration your logic. You can build the most robust, resilient pipeline possible without worrying that a 5-step fallback sequence is going to just bankrupt your sauce budget.
Exactly. It makes high-volume data processing exponentially cheaper.
Okay, there has to be a catch.
There is. The trade-off is what we call automation debt, because saving money on execution credits is only half the equation. Zapier silently maintains its 8,000-plus API integrations in the background.
Right. So when Facebook updates their lead ads API from version 16 to 17,
Zapier's engineers update the connector. You do absolutely nothing. Your workflow just continues to function. That is immense value.
definitely.
Make requires a bit more manual intervention with their module migrator, but it's still largely managed for you.
But with n8n, you are taking on that maintenance burden yourself, right? Especially if you're using custom code nodes. I mean, if an API endpoint deprecates, your custom JavaScript breaks,
Yeah.
and your engineer has to actually go in and fix it.
Yeah, you're on the hook for it. n8n really encourages you to treat your automation logic like actual software. They offer enterprise features like Git-based version control and multi-environment support.
Like dev, staging, and prod environments.
Exactly. You can build a workflow in a development environment, test it against a staging database, and then promote it to production.
I mean, setting up a full CI/CD pipeline with Git version control for a marketing workflow feels heavy.
It is heavy.
You're essentially trading $1,000 a month in SaaS fees for a portion of a senior engineer's salary just to manage environments and code deployment.
It's a real trade-off.
Yeah.
And the weight of that engineering overhead leads directly into the biggest architectural decision a company makes with n8n, which is where the infrastructure actually lives.
Ah, right. Because Zapier and Make are fully managed cloud platforms.
Yep.
Think of Zapier and Make like relying on a municipal water supply. You turn on the faucet, the water flows, the city manages the reservoir, the filtration plants, the water pressure, and all the compliance testing. You just pay your monthly utility bill based on your usage.
That's spot on. You never have to worry about server provisioning, security patches, or maintaining SOC2 Type 2 compliance. The platform handles GDPR adherence out of the box. You just log into a web browser, and the infrastructure is entirely abstracted away.
But self-hosting n8n is like digging your own well and building your own municipal filtration plant on your property. I mean, you have total ownership of the water, but you also have to maintain the pumps.
Right. And the reason enterprises are willing to dig that well is data sovereignty.
The security.
Exactly. A healthcare provider bound by HIPAA regulations or a financial institution handling raw transaction data, they often have strict compliance requirements preventing them from sending sensitive information through a third-party managed cloud like Zapier.
So they hosted themselves.
Yeah. By utilizing n8n's self-hosted community edition, the entire automation engine runs securely behind the company's own corporate firewall. The data literally never traverses the public internet to reach a proprietary SaaS server.
That makes total sense for an enterprise. But the reality of self-hosting is brutally complex, isn't it?
Yeah.
Like, I've seen teams spin up a single DigitalOcean droplet, install n8n, and think they're ready for enterprise scale. And then Black Friday hits, a campaign goes viral, and the server's memory instantly maxes out, crashing the entire automation infrastructure.
Oh, I've seen that exact scenario so many times. A single server setup is totally fine for internal tools, but at enterprise scale, self-hosting requires serious DevOps expertise.
What does that actually entail?
Well, first, you need deep knowledge of Docker containers just to deploy the application reliably. Then, you have to manage a PostgreSQL database.
Because n8n stores data.
Yeah, n8n doesn't just execute workflows. It stores all the execution logs for debugging. If you process hundreds of thousands of events, that PostgreSQL database will grow massive, it'll slow down, and eventually crash if you aren't optimizing the queries and managing the storage volumes.
Okay, but how do you actually prevent that memory crash during a massive traffic spike?
Yeah.
I mean, you can't just keep buying bigger and bigger servers.
No, you can't. You have to configure n8n to run in what's called queue mode, which requires introducing a third component, Redis.
Redis, right?
Redis acts as an in-memory message broker. So instead of the main n8n server trying to execute 10,000 concurrent webhooks itself, which would crash it, it simply receives the webhooks and pushes them into a Redis queue.
Ah, it forms a line.
Exactly. You then spin up multiple separate worker nodes, so additional servers dedicated purely to processing. Redis distributes the jobs to the available workers. This is horizontal scaling. If traffic spikes, you spin up more workers. When traffic drops, you spin them down.
Wow. So you literally need an engineer who understands Docker, PostgreSQL optimization, and Redis message brokering just to keep the lights on. That completely changes the return on investment calculation.
It really does. Self-hosting n8n provides ultimate security and infinite scaling potential. But you're right, it shifts the cost from your software budget directly to your payroll.
Okay, so we've mapped out the logic limits, the mathematical traps of API polling, and the heavy reality of infrastructure. But there is a massive shift happening right now that is forcing companies to reevaluate all of this.
Oh, absolutely.
These automation platforms are no longer just, moving data between databases. They are becoming the hands and eyes for autonomous AI agents. Every technical team I talk to is currently obsessed with implementing MCP and RAG.
And the approaches these platforms are taking to AI integration are completely divergent. Like Zapier is leveraging its greatest asset, which is its sheer volume of integrations, through the Model Context Protocol, or MCP.
Can you break down what MCP actually is?
Sure, MCP is essentially a standardized, secure tunnel that allows an external AI model like Claude or ChatGPT to directly access software tools.
Okay, so instead of a user typing a prompt to generate an email draft and then manually copying that draft into Gmail.
The AI uses MCP to reach through Zapier, open the Gmail API, and draft the message itself.
That's incredible.
It is. And beyond just drafting an email, an AI agent could use Zapier's MCP to query your CRM for a client status, update a Jira ticket, and send a Slack message summarizing the changes, all autonomously.
But letting AI just run wild in your system sounds terrifying from a security perspective. Like shadow AI employees giving random AI models access to company data.
Right, which is why the real enterprise value of Zapier's MCP integration isn't just the connectivity, it's the IT governance.
Oh.
Zapier acts as the centralized governance layer. An IT administrator can set strict guardrails on exactly which actions an AI is allowed to take via MCP. And more importantly, Zapier provides a single unified audit trail. You can see every single API call initiated by an AI across the entire organization in one dashboard.
That is massive for compliance.
Huge. Now, Make is approaching AI slightly differently. They seem focused on deploying AI as highly capable functional modules within their visual canvas.
Functional modules, like what?
Well, Make allows you to drop a native OpenAI or Anthropic node directly into a workflow to perform complex transformations.
So instead of code, it's AI.
Exactly. Say you receive an unstructured PDF invoice via email. You can route it to an AI node that is instructed to extract the vendor name, the total amount, and the due date, format it as strict JSON, and pass it down the pipeline to your accounting software.
So Make is basically using AI to replace the brittle rejects and data extraction tools we used to rely on.
Exactly. It's a functional block. But the real frontier of AI orchestration, the deeply technical execution of RAG pipelines, that is where n8n is really pulling ahead.
RA stands for Retrieval Augmented Generation.
Yeah.
But what does that actually mean mechanically within a tool like n8n?
Well, AI models are constrained by their training data, right? They don't know anything about your company's proprietary internal engineering documentation.
Right, they only know what's on the public web.
Exactly. A RAG pipeline solves this by securely retrieving your internal data and feeding it to the AI alongside the user's prompt. And n8n natively integrates LangChain, which is a specialized framework for building these complex AI architectures.
So it's not just a node that sends a prompt to an API. n8n has basically built an entire orchestration layer for AI components.
Yes, you can visually connect an AI agent to a vector database like Pinecone, which stores your company's documentation in a format the AI can mathematically search. But the most critical component n8n introduces is the memory manager.
Because AI models don't naturally remember anything.
Right, an LLM API has no inherent memory. Every call is a blank slate. If you want an agent to have a multi-turn conversation with a customer, you have to constantly feed it the entire history of the chat. n8n's memory nodes automatically manage the context window, summarizing older messages and managing token limits so the AI actually remembers what was said 3 steps ago.
Oh, that takes so much heavy lifting off the developer. So what does this look like in practice? If I want an autonomous AI to read a customer complaint, search our internal knowledge base for a solution, and then draft and send an email, which tool actually handles that best?
Well, the structural advantage LEN has here is sub-workflows.
Sub-workflows.
Yeah. You can build a system where Agent A is configured to strictly classify incoming support tickets. If it classifies a ticket as technical, it triggers a sub-workflow containing Agent B. Agent B is armed with a vector database search tool. It searches the internal wiki, retrieves the solution, and generates a response. The output of Agent B is then passed back up to the main workflow to be emailed to the customer.
So you are basically building an autonomous team of highly specialized agents interacting with each other, passing context back and forth, entirely governed by n8n's error handling and logic nodes.
Exactly. For a company that needs to build highly custom, secure AI pipelines that process proprietary data behind a corporate firewall, n8n's architecture just provides tools that Zapier and Make simply do not have.
But if you just want a chatbot to trigger actions across a huge variety of SaaS apps quickly, Zapier MCP is the clear winner.
Oh, for sure. Zapier for breadth, n8n for depth.
So the overarching lesson from analyzing the documentation, the pricing structures, and all those developer forums is that searching for a single best platform is just a flawed strategy.
Very flawed.
The most sophisticated go-to-market teams actually operate a hybrid infrastructure.
You have to. You leverage the specific architectural strengths of each tool while avoiding their operational weaknesses.
Right. You utilize Zapier for simple point-to-point integrations and lightweight MCP actions where speed of setup is paramount and logic is minimal. You deploy Make for massive array processing, visually routing complex data payloads where you need to see the flow of information without, managing a bunch of code. And you dedicate an engineering team to self-host n8n for ultra-high volume data processing and orchestrating complex LangChain AI agents where security and custom logic are just non-negotiable.
Exactly. A hybrid approach prevents you from hitting the scaling limits of any single platform.
But, as we look at the evolution of LangChain and the Model Context Protocol, there's a serious question about the future of this entire industry.
Oh, definitely.
I mean, we spend so much time visually mapping out these decision trees, dragging a router onto a canvas, setting up filter conditions, configuring API headers. But as AI models gain the ability to autonomously chain tools together and understand API documentation natively, the mechanics of automation are going to shift dramatically.
The visual workflow builder itself might just be a temporary bridge.
Exactly. We are rapidly approaching a reality where you won't build a visual flowchart at all. You will simply give an autonomous agent a secure MCP tunnel and a goal like audit all Tier 1 support tickets from yesterday and update the corresponding CRM records. And the AI will dynamically construct, execute, and troubleshoot the required API calls entirely in the background.
The drag-and-drop canvas might soon look as antiquated as a physical switchboard.
It's a wild thought to mull over. Well, thank you for joining us on this deep dive. Before your current infrastructure buckles under the weight of your next campaign, take a hard look at how your data is actually moving. We'll catch you on the next one.